Hello, we are going to look at types of collisions. In this video, we're going to look at elastic, inelastic, and explosion collisions and how to calculate for those. Alright, starting with question number 1. When these two freight cars of different mass collide and couple, what will be their resultant velocity? Now, as we've been talking about elastic collisions, there's a little bit of difference here. Okay? In elastic collisions, we calculate each object's mass and velocity before and after. But in an inelastic collision, now their mass is going to be all one mass. So the equation looks a little bit different. So we're going to have the mass times the velocity of object 1 and the mass times velocity of object 2. And those are going to get added together for our total momentum. And just like before, conservation of momentum, the momentum of the objects when they're separate is still going to be equal to the momentum after the objects are together. Alright, so let's look at how that looks. So for object 1, right, this train car, its mass is 10 tons times a velocity of 4, and object 2 has a mass of 30 tons times a velocity of 0. So I'm going to go 10 times 2 is 40. Sorry, 10 times 4 is 40. And 30 times 0 is 0. So that means the total momentum of these two train cars is 40 tons ton meter per second. So this would be the unit we'd use because we're not using kilograms, we have tons. Then over here, right, we're going to have our mass times our velocity. Now, our mass is the mass of both of the cars, right? So the car was 10 and 30, and all together the mass is 40. So we're going to have 40 times our velocity. Right? So we'll just kind of squish this equation a little bit closer. If our momentum of all the cars, right, the total momentum is 40, and the mass is 40 times the velocity, we have to solve for v. We're going to divide both sides by 40, because 40 divided by 40 is 1. That leaves us with 1v. Whatever we do to one side, we do to the other. And so our velocity is 1 meter per second. Again, the big difference being that instead of having a separate mass and velocity of both objects at the end, right, they're combined into one mass because it's an inelastic collision. Let's look at question number 2. A 2 kilogram blob of putty moving at 4 meters per second slams into a 6 kilogram blob of putty at rest. What is the speed of the two stuck together blobs? So let's look at this problem. We have two separate blobs. They come together and they are stuck together. So we know that this is an inelastic collision. So we're going to be doing the same thing as we did before. We have our mass and our velocity of our first object plus our mass times our velocity of our second object. And that's going to be equal. So this is going to give us our momentum of the whole system before the collision. And after the collision, there's only one mass, and that mass will be going one speed. So let's look at blob of putty. Blob number 1 is 2 kilograms traveling at 4 meters per second. Blob number 2 is 6 kilograms and it is at rest. 2 times 4 is 8. 6 times 0 is 0. So 8 plus 0 is 8. So the momentum of the system, the momentum of the two blobs together before they collide, is 8. Now, what is their mass? Their mass is 2 kilograms plus 6 kilograms. So we have 8 kilograms. So we're going to have 8 times velocity. We have 8 v's. We want 1 v. So 8 divided by 8. Right, we're going to divide both sides by 8 because 8 divided by 8 is 1. Whatever we do over here, we do over here. So 1 is equal to 1 meter per second is equal to our velocity. Now the answer isn't always 1. It just happens to be in these two questions. Let's look at question number 3. A football player runs at 8 meters per second and plows into an 80 kilogram referee standing on the field, causing the referee to fly forward at 5.0 meters per second in a perfectly elastic collision, meaning these two are going to be separate, come together, and be separate again. What would the mass of the football player be? So in this case, this is one of the cases where we're going to have to find the mass. So we have our object 1, object 2. Oops. Again, this is our total momentum, is going to be equal to object 1 and 2. So a football player runs at 8 meters per second. We don't know his mass, so we're going to leave that variable, but it's times 8. And it plows into an 80 kilogram ref. That is not moving at all. He's standing there. We don't know the mass. And it says he plows into the referee, causing the referee to fly forward. The referee is 80 kilograms times 5. And if he plows into the referee, I'm going to assume, it doesn't say it, and it should, because we need to be explicit in problems. If he plows into him, I'm going to assume that the football player stops. So I have 8 times m is 8m, plus 80 times 0 is 0, equals, so I have 8m equals, well, this is 0, and this is 80 times 5, that is 400. So 0 plus 400 is 400. So 8m equals 400. To get 1m, I'm going to divide by 8 because 8 divided by 8 is 1. So 1m, whatever I do to this side, I'm going to do to this side. And I'm going to have 50. $50 kilograms is our mass. We could substitute in and see if it makes sense. If he did in fact come to a stop, 50 times 8 is 400, plus 0, so this is a total side of 400. 50 times 0 is 0, plus 400. So we have 400 equals 400. We have equal momentums on both sides. We're going to skip ahead to an explosion equation, to an explosion one. So we have the rifle. Calculate the velocity of the rifle's recoil after firing. So the rule for explosion equations, we are starting with two objects, right? We're going to have the bullet and we're going to have the gun. the rule for our explosion equations is that the objects are starting at rest, and therefore our momentum, our total momentum, of the whole system is going to be 0. Because our momentum, right, is also going to be equal. So let's look at why it's 0. To start with, object 1 has a mass of 4, but it's not moving. The bullet has a mass of 0.01 times 0, right? It's 0. So our momentum is equal to 0. That doesn't mean that the objects don't begin moving. What that means is that the momentum of object number 1 is going to be opposite but the same magnitude as object 2. So if this is, for example, positive 20, that would be negative 20. So we're going to go ahead and look at this. The mass of object 1, which is our gun, is 4 kilograms, and the velocity of the gun, we don't know. We know the mass of the bullet is 0.01 times a velocity of 300. I don't know what this is, but I know it's 4v plus 0.01 times 300 is 3. So let's rewrite my equation just a little bit neater. 0 is equal to 4v plus 3. I have a constant, I have a variable expression, and I have a constant. In order to solve algebraic equations, we need all our constants on one side. So I have this 3, so I need to get this. It's 3 has been added to 4v. I need to subtract 3 from both sides. So I'm going to have negative 3 equals 4v. I'm going to divide, so now I have 4 times v. I'm going to do the opposite of that. I'm going to divide, because 4 divided by 4 is 1. Whatever I do to one side, I do to the other. So negative 3/4, which is negative 0.75, is equal, so negative 3 divided by 4 is negative 0.5, equals velocity, so meters per second. We can double check this. I'm going to go back to object number 1. Now, if this momentum was 3, this should equal negative 3. So let's check this out. 4 times negative 0.75 should equal negative 3. 4 times negative 0.75 equals 3, equals negative 3. We're good. That tells us, right, because negative 3 plus 3 equals 0. And this is how we do an explosion equation.